Hello everyone, welcome to this video. So in today's session, we want to look at these two questions from mathematics. So let's just quickly dive in and see what we can do to solve these two questions. So the question says evaluate. So the first one says the integral of x squared minus 2x plus 5 dx. Part 2 says integrate from 0 to 2 3x squared minus 4x plus 6 dx. So before we can answer these two questions, let's just first of all understand something about how we can integrate simple functions. So let's suppose we have a function. So let me call this function g. So let me call this function g of x. So we have a function g of x and it's equal to axn plus b. So if we want to integrate that function with respect to x, in other words, we want to find the integral like that. So we want to find this. So we read this as the integral. So to read this expression, we would say the integral of axn plus b dx. So every time you have such type of a function and you want to integrate it, what you just need to do is this. So ax, you increase the power by 1. So the power here was n. It becomes n plus 1. Then you divide by the same new power. So you divide by n plus 1. Then plus, so this b has no x. So all you need to do is give it an x. Then plus c. Always add a constant c. So this type of integral where we are not getting the exact value and we are adding c, we call it the indefinite integral. So it's called the indefinite what? Integral. So when you're finding the indefinite integral, you're not finding the exact value, you're not finding the exact area, and you always need to add the c, the constant. So let me give you an example. Let's say you're asked to integrate 3 x to the power of 4 minus 2x squared dx, like that. So what we need to do here is it's pretty easy. So it will be 3x. You can see here we have x power 4. So you increase the power by 1. So it becomes 4 plus 1. Then you divide by this same power. So you divide by 4 plus 1. Then we have negative 2x squared. What do we do to it? So it will be negative 2x. The power here is 1. So you add 1. I mean the power is 2, you add 1. Becomes 2 plus 1. Then we divide by the same 2 plus 1, like that. Then we always add what? Constant c. Take note here, we don't have a term without an x. That's why we just went straight like that. Then what do we do here? So this becomes 3x, 4 plus 1 is 5, then over 5 here. Then minus 2x, 2 plus 1 is 3. Then you divide by 3, and then plus c. So this gives you the answer, okay? Now what if, so the same applies if we have something like this. Let's say 2x squared minus x to the power, let's say we have 4x minus x squared plus 5 dx. We're asked to integrate that. So what do we do? So first of all, remember that if you just write x, the power is always what? 1. So there's a power of 1 here. So we do the same thing. 4x, the power is 1, so it becomes 1 plus 1. Then we divide by 1 plus 1. Then minus x, the power here is 2. We add 1. Then we divide by the same thing, okay? 2 plus 1. Then this one has no x. What do? We just give it an x. So it becomes plus 5x. Then because this is an indefinite integral, we need to add the c. Then all we need to do now is Simplify. So this is 4x, the power now becomes 2, then we divide by 2. Then minus x, the power 3, because 2 plus 1 is 3, divided by 3. Then plus 5x plus c. So 2 into 4, we have 2 now, the x squared minus x to the power 3 over 3, then plus 5x, then plus c. So that gives us the answer. This one here. Okay, so let's just look at another example. So let's say you're now asked to integrate this. We have 4 x to the power 3 minus 2 over x squared plus 6. Okay. So integrate this with respect to it. So sometimes they'll just say integrate with respect to x, or they will say find the integral of this. Okay, or they'll just give it to you like this. So what do? First of all, you should see the middle term here. The middle term is not in the standard. Remember, our standard is a x to the power n. We should see the power there in this form. So you can see that here it's at the bottom. So what do? We first of all change it to that form. Okay? Then I want you to know something. If you have something written like 1 over b to the power n, you can always take this term to the top there by changing this to negative. So this simply becomes 1 times b to the power n, but this n, because it has now gone to the top, becomes negative n like that. So if I have 1 over 2 to the power 3, this is the same as saying 2 to the power negative 3. If I have 1 over, or if I want, I can even put 3 over 5 to the power negative 2. This is the same as saying 3 times 5 to the power 2. This changes to, you just change the sign there. But here I put negative, that's why it's become positive there. Yeah. Let me give you something that we can easily use here. So if I have 2 over x to the power negative 5, this becomes, you take this to the top, becomes 2x to the power 5. Or if this was positive, usually positive, I don't know why I'm putting negative there. So if I have 2 over x to the power 5 like that, this becomes 2x to the power negative 5. If I have 2 over, or I can 3 over x to the power any number 2, this becomes 3x to the power negative 2. I hope you get the idea. So that is what you do. You just change the sign of the power. Yeah. And you take it up. So that's what we're going to do. You need to observe here that this is in the bottom. So we take it to the top there. So first of all, so it will be 4 integral of 4x to the power 3. This, you change the form of that one, becomes negative 2x to the power negative 2. Remember, it's positive, so it becomes negative. Then plus 6 and dx, like that, okay? What do we do here? We now apply the power rule. The power rule is what we've been doing now to integrate this. So once we apply the power rule, so this becomes 4x 3 plus 1. Then what do? We divide by the same new power, so over 3 plus 1. Then minus 2x, this is negative 2, but we always add the 1 there, so plus 1. Then we divide by negative 2 plus 1. Then plus 6, what do we do to 6? We give it x. Then always plus 6, because this is an indefinite integral. Okay, so let's simplify. This becomes 4x to the power 4 divided by 4, because 3 plus 1 is 4, minus 2x, negative 2 plus 1, so negative 2 plus 1 is negative 1. Okay, so this will give us negative 1. Then we divide by negative 1. Then plus 6 plus 6. Okay, then you can see 4 and 4 go, so we remain with x to the power 4. This negative and this negative will form positive, so we're going to have positive. So what do we have? So 1 into 2 is literally 2. So it will be 2x to the power negative 1. Then plus 6x plus c. This is okay, this is acceptable, but if you want, you can now take it back because there's a negative power. If you want to maintain positive powers, you can say this is x to the power 4 plus, if we take it back, remember this is the power is only to x. So this becomes 2 over x to the power 1. If you want, you can say 1 there, but x to the power 1 and x, the same thing. So you can just say x like that. Then plus 6x plus c. So this is what you do. This is how you answer this question. Now, what if we have something that looks like this? So 0 to 2, x squared plus 2 dx. So you're now integrating this from 0 to 2. So every time you integrate a function between two limits, what you're doing to that function is you're finding the area under the graph between that region, the specified region. So here, we're integrating from 0 to 2. So imagine you have this graph, y, x. Not this function. Let me just pick a random function. If I have a random function that looks like this, and I integrate this function from this value of x, let me call it x1, to this value of x, let me call it x2. Once I integrate this function, I'm finding the area under the function, under the graph. Okay? So the area between that graph and the x-axis. So I'm finding this area. Okay? So I'm finding the area between x1 and x2. So we call, so every time you have this a, b, g of x dx, you are trying to find the area of this function g of x between the limits a and b. So you're finding the area between the graph and the x-axis. We call this, the b value, we call it the upper limit, the upper bound. We call this the lower bound, the lower limit. So like the lower value is the lower limit. The higher value is the upper limit. So if you also have another function, let me just say you have a random function like this. Which function should I use this time? Like that. Then you integrate this function, then you also integrate it now between these limits. Let me call this a, and let me call this b. So once you integrate this function, you are now finding the area below the function, below this function, but between a and b. So you're finding this area here. That's what you want to know. So if this was my function h of x, I'm finding the area of this function. To find the area of this function, I need to integrate from a to b. I'm integrating from a to b. So what am I integrating? I'm integrating the function h of x with respect to x. So this will give me the area. Now the question is, how do we integrate every time we have these limits? Okay, so once you have these limits, you're now finding the exact value. You're finding the exact area. We now call these limits the definite what? Integrals. So every time we have definite integrals, we shall give you the limits between which you are integrating. So from 0 to 2, integrate this one. So what do we do? So let's see what we are supposed to do. So for example, let me just pick this one. Let me bring it here. Let's integrate it. So let's find the definite integral. We are finding the area of this function. So if you were to graph this function, actually this function looks like, what's this being? So because it looks like this. Then from 0 to 2, 0 to 2, somewhere here. So we're trying to find that area. Okay, you don't necessarily need to know the shape of the function. What I just want you to understand here is how to evaluate this integral. So the question will come, evaluate this. So integrate from 0 to 2, x squared plus 2 dx, okay? So we apply the same rules. X, 2 plus 1, the power increases by 1. Then we divide by 2 plus 1. Then we can see this one has no x, we just give it x. Then from 0 to 2, okay? So you're integrating from 0 to 2. So that is why, that's what makes it a definite integral, because we are finding the definite value here, finding the area. So this one becomes x to the power 3 over 3, then plus 2x. Then what do we do with the limits? 0 to 2. So what you do with the limits, you say f of 2 minus f of 0. So you take the upper limit, you plug it in for you substitute for the value of x. Then minus, you take the lower limit, you also substitute for the value of x. So that is what you want to do here. So f of 2 minus f of 0. So what I mean here is, first of all, you take 2, you put it where there's x there. So we shall have 2 where there's x, but it's to the power 3. Then over 3. Then plus 2, where there's x again, we put 2 there. See? So once you substitute 2 in for the value of x, we now say minus this one. This 0 should also do the same. This is 0. 0 should also do the same, meaning where there's x, I put 0. So it will be 0 to the power 3 over 3 plus 2, where there's x, I put what? 0. Like that. So this is what we mean by f of 2 minus f of 0. Then after that, we simplify this. We also simplify that, then we subtract them. So 2 to the power 3 means 2 times 2 times 2, 3 times 8 over 3. And 2 times 2 here is 4. Minus. You can see that we have zeros everywhere here. Here I'll get 0. 2 times 0 is 0. When I add 0 plus 0 is 0. So the result from this side is simply a 0. So we just need to simplify here because 0 means nothing. So 3 times 4 is 12 plus 8 is 20. So we shall get 20 over 3. So this is the answer, which you can simplify because when you subtract 0, it will still give you this. So 3 into 20 goes there 6 times, remainder 2 over 3. So that is the value and that is the area. So this area here. Okay, so let's now go back to the questions that we had earlier. Let's see if we can apply this now, this information, and find the answers. Okay. So the question says evaluate. So part 1, let's start with 1. So 1, we need to integrate x squared minus 2x plus 5 dx. So let's integrate that one. You can see this is an indefinite integral. We are not finding the exact value. So always remember to add c. So let's start. The same procedure. So it will be x to the power 2 plus 1 over 2 plus 1. The next step, negative 2. What do you want to remember here? This one has power 1. So minus 2, x, because it's power 1, to be 1 plus 1, we always add 1 over 1 plus 1. And what do we do to the 5? We give it an x. Then always remember plus c. Okay. Then what else? So this one becomes x to the power 3 over 3. So minus this one, negative 2x squared, because 1 plus 1 is 2, then over 2. Then plus 5x plus c. We simplify and say x to the power 3 over 3. This one and that one will go. So we remain with minus x squared like that. Then plus 5x plus c. That is what you're supposed to do. And this gives you the answer. Okay. Let's now go to part 2. So part 2 says we are now integrating this one from 0 to 2. So this one is a definite integral. So we're integrating from 0 to 2, 3x squared minus 4x plus 6 dx, like that. So the same procedure, 3x, this one becomes 2 plus 1, okay? Then over 2 plus 1. Minus 4x, there's power 1 here. Remember that when I write x, there's power 1 here.